3I Atlas has been mysterious from the start, but what Avi Loeb just revealed has shifted the entire conversation from strange interstellar visitor to possible scientific turning point.
Today's November 13th. If you go to uahighrise.org, they posted pictures from Mars today, but they can't post these 3I Atlas pictures from October 2nd. So bizarre. How do you respond to that?
Because according to Loeb, Harvard astrophysicist, interstellar research pioneer, and the most controversial voice in modern astronomy, 3I Atlas is not behaving like a typical comet, asteroid, or even a damaged debris fragment drifting between stars.
I expect the high-rise image to show a fuzzy ball of light, like the Hubble image did, but I hope to be surprised.
What he's suggesting is far more radical, yet grounded in data the scientific community can't easily dismiss.
I don't necessarily think they are trying to do something, on purpose. It may be just bureaucracy taking over science.
I agree, and that seems like a whole lot of bureaucracy. Again, those photos taken October 2nd. It's November 13th.
Loeb isn't claiming aliens. He never starts there. He always starts with evidence. And the evidence of 3I Atlas, he argues, points toward a pattern that is now too consistent to ignore, a pattern that connects Oumuamua, 3I Atlas, and the possibility that interstellar space may be full of technological artifacts that we have been too blind or too arrogant to recognize. His new analysis doesn't settle the debate, but it makes it impossible to keep pretending nothing unusual is happening.
Including the two most important ones, the mass being orders of magnitude larger than the previous two interstellar objects. Based on the size estimate we have, the diameter is so much larger that the mass is 1,000,000 times more than the first interstellar object, Oumuamua, and 1,000 times more than the second, 2I Borisov.
Loeb's focus begins with the two key features that have emerged in recent observations: the object's unexplained trajectory shift and the JWST detection of narrowband light it shouldn't be producing. To established astrophysicists, these anomalies are inconveniences, things to be explained away with natural models. Outgassing that can't be detected, dust that doesn't appear in spectra, thermal processes that contradict the object's temperature. Loeb simply points out the obvious. If you have to create invisible physics to defend a natural explanation, maybe you're defending the wrong thing.
Well, we know about comets in the solar system, but this one has a number of puzzling properties, and that's what makes it a very interesting subject for future research for us to figure out those things, because we don't understand them.
His starting point is brutally simple. When a hypothesis fails repeatedly, it's time to consider alternatives. And with 3I Atlas, every conventional hypothesis has failed. The cornerstone of Loeb's new argument is that 3I Atlas displays two highly unusual characteristics observed previously in only one interstellar object, Oumuamua. Both objects show non-gravitational acceleration without any detectable outgassing. Both exhibit abnormal reflectivity or emission patterns that contradict thermal models. Both possess shapes or material properties outside the known categories of natural small bodies. And both seem to exhibit behavior that aligns more with engineered material than with comet cores or fractured asteroid remnants. The scientific community didn't like Loeb's conclusions about Oumuamua. They disliked even more the idea that 3I Atlas could be another data point in the same direction.
We are talking about that interstellar object known as 3I Atlas. Most scientists think it's a comet, but one high-profile Harvard astronomer has been making the case on this show and other places that its anomalous behavior and characteristics suggest that it might be alien technology of one kind or another.
But science doesn't care what makes people uncomfortable, and Loeb is leaning directly into the discomfort. His recent reveal highlights three major threads.
What is strange about the jets is that they are tightly collimated and the object is supposed to rotate every 16 hours. So then the question is, why isn't that rotation smearing the jet?
The first thread involves the anomalous trajectory readings. Loeb points out that the observed deviation is too smooth and consistent to be noise or a simple impact event. Objects don't accelerate this way unless pushed, he says, and if we don't detect a natural push, then the push might be something else. In other words, If something is altering the motion of 3I Atlas, but the known forces don't fit, the responsible force may be unknown. This is exactly the same problem astronomers wrestled with in 2017 when Oumuamua sped up slightly as it left the solar system. Most scientists chalked it up to exotic outgassing. But no gases were seen. No dust plume. No chemical signatures. Nothing. And now it's happening again. The second thread concerns the recent JWST detection of a narrow, unexpected emission line. Loeb calls this the smoking signal. Natural objects, he argues, do not select a precise wavelength to emit or reflect in unless they contain highly specialized or exotic materials. This is not broad thermal radiation, he notes. This is targeted emission. He is not saying it's artificial, but he is saying the physics behind it may not exist in our current classification system for interstellar debris. And if two interstellar objects in a row display exotic optical properties, the likelihood of coincidence collapses rapidly. The third and most provocative thread is the statistical argument. Cosmic randomness should produce a variety of interstellar objects: icy, rocky, metallic, dusty. But out of the three we've detected so far, two are anomalous in similar ways. If every interstellar object behaved like Borisov, Loeb notes, we would have confidence in natural explanations. But when 2 out of 3 disagree with our models, the models, not the objects, become suspect. He goes further. He suggests we might be dealing with an entirely new class of objects: interstellar probes, debris, sails, or fragments from civilizations long gone. Not active ships, not functioning machines, but technological remnants drifting through the galaxy for millions of years. The Milky Way is 100,000 light-years across. Civilizations could rise and fall long before their technology stops moving. If humanity were gone tomorrow, Voyager 1 and 2 would continue drifting for billions of years. They would become someone else's interstellar anomalies. Loeb argues that assuming we are the first civilization in the galaxy is statistically absurd. So is the assumption that no technological debris from older civilizations would ever drift near our sun. His position is clear. We are observing something unexpected, and the burden of proof does not lie in making excuses for models that don't work. It lies in following the evidence wherever it leads. But Loeb's reveal goes beyond theory. He brings data that other astrophysicists are struggling to rebut. One major detail he highlights is the ratio of reflected to thermal energy. 3I Atlas appears to be bouncing back more light than its thermal signature predicts. This suggests an ultra-thin or non-solid surface, something like a reflective sheet, foil-like material, or layered composite. Natural objects rarely form these structures. Engineers do, and not necessarily alien engineers. Any sufficiently advanced or ancient civilization could leave behind materials with optical behavior we do not yet understand. He also emphasizes the unusual stability of the narrowband light detected by JWST. Natural fluorescence fluctuates. Thermal emission broadens. But the 3I Atlas signal remained clean, stable, and precise in repeated passes. If this were a rock, Loeb argues, it would not behave like a perfectly tuned optical resonator. Of course, the mainstream astrophysics community is pushing back. They claim the data needs more analysis, that the signal might be noise, that the deviation might be misinterpreted. But those counterarguments weakly mirror the ones used during the Oumuamua controversy, arguments that ultimately resolve nothing. Loeb, meanwhile, keeps stressing that science must not censor possibilities simply because they are uncomfortable. If the evidence points towards something exotic, scientists must investigate it, not ridicule it. His central message is that we need to treat interstellar objects like 3I Atlas as serious scientific opportunities, not as problems to be explained away. The wider implication of his new reveal is profound. If 3I Atlas contains exotic material or shows signs of non-gravitational motion from unknown forces, we may be witnessing our first glimpses into technologies or materials formed outside the solar system, whether natural or engineered. That alone would reshape astrophysics. But if Loeb's most daring hypothesis proves correct, if these objects are fragments of ancient technologies, then 3I Atlas isn't just a rock from another star. It's a message from another civilization's past, drifting silently into our cosmic neighborhood. Even the harshest critics agree on one point. We need more data, and fast. 3i Atlas is moving quickly, growing dimmer by the week. Soon it will be beyond the reach of telescopes, even Webb. Whatever clues it holds about its origin, composition, or purpose will be lost unless astronomers capture them now. Loeb's reveal has already catalyzed an acceleration in observational scheduling. Infrared arrays, high-resolution spectroscopes, and deep sky sensors are being retargeted toward the object. If the emission line intensifies or shifts, it could confirm the presence of exotic materials or coherent optical processes. If its trajectory drift continues in a smooth curve, it may indicate persistent external forces, natural or otherwise. And if both anomalies strengthen simultaneously, the debate will end instantly. Loeb is also pushing for missions aimed at intercepting future interstellar objects, fast-response probes that can launch on short notice. We missed Oumuamua, he says. We're losing 3i Atlas. But the next one, we must not let it pass unexamined. His point is simple. If the galaxy sends us visitors, we need to be ready to greet them, not watch them disappear into darkness. In the end, Loeb's revelation doesn't claim certainty, only urgency. He believes 3i Atlas might be the most important interstellar object we've ever detected, not because it proves aliens exist, but because it proves our understanding of interstellar matter is incomplete. And when two objects in a row break the rules may need rewriting. Whether 3i Atlas is natural, exotic, engineered, or something entirely unimagined, Loeb is right about one thing. This is not the time for dismissal. It is the time for inquiry. It is the time for courage in science. And if what he revealed turns out to be true, then 3i Atlas won't just change astronomy. It will change humanity's place in the universe.